Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Matsidiso Kongwani. This lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center and broadcast by Pagama Research and Development. Our today's lesson is on Euclidean geometry of circles, the grade 11 geometry. And then grade 12, you are more than welcome to send your questions or your solution to the WhatsApp number 063 629 3655. Please note it down. It's 063 629 3655. Okay, let's continue with the business of the day. And then the objectives of today's lesson are, after completion of the lesson, you will be able to solve Euclidean geometry riders or apply the Euclidean geometry of circles. And then remember, grade 12, this topic worth 40 plus minus on our paper 2, 40 plus minus. And then now let's start with the parts of the circle. How do we name certain parts in our circle? Number one, we are having an arc. As you can see, this is the minor arc going on the blue part there. And then we can also have the major arc, which is the black part of the circumference of that circle. Remember, that outer part of your circle is the circumference. And then now we have a secant. A secant is a line that is touching a circle at 2 points. As you can see that it is continuing outside the circle. Okay, do not mix this one with the diameter now. Look at the diameter. A diameter, it's a line that starts from the circumference of the circle, that from that point, passing through the center to the other part of the circumference of the circle. Therefore, it must have two parts touching the circumference, but this line must pass through the center. Therefore, it is a diameter. And then let's compare this to the chord now. A chord is a line that starts from one side, touching the circumference, to the other side of the circumference. Look at this. This is also touching the circumference at 2 points, but a chord is not passing through the center. Okay, grade 12, that is the difference between a diameter and a chord. They both touch the circumference, but a chord does not pass through the center. Now, we sometimes call a diameter a special chord. Why? Because it also touches the circle at 2 points, from one side of the circle touching the circumference to the other side. The only difference, we call this special chord. Why? Because it passes through the center. So a diameter can also be a chord, but it's a special one because it is passing through the center. There we have our center point in the middle of the circle. And then this diameter line also, it cuts our circle into two equal halves. Therefore, it forms semicircle. Semi meaning half. Therefore, it forms semicircles. And then we have a radius. And what is a radius? A radius is a line from the circumference to the center of a circle. That means now a radius is half of a diameter because it is from the center to the circumference, center to the circumference. Therefore, we have another radius there. Again, from center to circumference, we have another radius there. As you can see that in order to have a diameter, we are having a radius by a radius. So if you combine two radius, they form a diameter. Okay, and then now we have a tangent line. A tangent line is a line that touches a circle at 1 point. Okay, and then this point must be out, not inside. Ne? If you have a line that like that one, this cannot be a tangent because it is now going inside the circle. To be a tangent, it must touch a circle at 1 point of contact, and that line must be outside the circle. Therefore, we have a tangent line there, grade 12. And then now we have what we call a sector. We are using sectors when we do angle, circles, and circular movement. Therefore, a sector is when you cut off this yellow part here, and then this now forms a sector there. That yellow part is our sector. Okay, grade 12. I hope now you will understand the language as we will be applying these names of different parts as we continue with this Euclidean geometry. Right, and then now we have the general hints when solving geometry problems. These are very useful tips, grade 12. Number one, what must you do when you see a rider? You read the given statement twice. You repeat it again to ensure that you understand everything that is given to you. And then step number two, ensure that all the given information is indicated on the diagram. So you are checking as you are reading for the first and the second time, all the given information on the statement, is it indicated on the diagram? And then number three, you analyze and note down all. Analyze the diagram, note down all theorems that are appearing on the diagram. Okay, and then step four, you use different colors now. Use colors for geometry grade 12. Have those coloring pens with you. And then you use different colors to mark off equal angles and equal sides on your diagram. And then step five, start from the given angle to track the solution. Always from the given to unknown. Given to unknown. And then the last step, after calculating any angle, put the information on the diagram because it might help you to answer the questions that follow. Okay, and then now we are having four categories or four classes of categorizing this Euclidean geometry of circles. So the first class, we are going to have theorems that falls under the center theorems. How do we identify this? They must have a center on the diagram. So the first theorem that we classify as the center theorem is the theorem that states that a line from center perpendicular to the chord. So if a line is drawn from center and then to the chord, and then you find that this line is perpendicular to that chord, that means what is given to us is perpendicular here. So we are given that line OE is perpendicular to line CD there. How do we know that? By seeing a 90-degree curvature. If that information is given to you, you can now conclude that the CE is equal to the ED line. So we simply state that the line CD is bisected. To bisect is to cut into two equal parts. Okay. For an example, if I can just have a circle and a line from center to a chord, and then there is no indication of 90 degrees grade 12, I cannot conclude any bisection. To conclude this theorem, 190 degrees must be there, okay, or either a bisected line must be there, which is the converse of this, okay. And then the converse states that a line from center to the midpoint of a chord. That means you will be given a line from center to the middle point, to the midpoint, middle point. Middle point, that means, therefore, as you can see, you have those dashes there. That is the given information. Then, if you are given a line from center bisecting a chord, therefore, the angle here, you can conclude, therefore, this angle is equal to a 90 degrees. And then this falls under center theorem because we are talking of lines from the center there. That will be our first theorem and its converse. And then let's look at the second center theorem. The second center theorem will be the angle at the center is twice angle at the circumference. And then grade 12, what are the misconceptions here? Most learners, they only look for angle center, twice angle circumference when they have this first particular diagram. Be careful, grade 12, we have four diagrams that we can identify under this particular theorem, angle center, twice angle circumference. All right. And then now we have a center. That is why we call this the center theorem. And then this will be our angle at the center. So we track lines that comes from that center point. There we have the line OC and the line OB. And then these lines must now go and touch the circumference. And then from the circumference point, you must be able to trace the angle at the circumference now. Starting from those circumference point, going to the circumference, can you see that we have line A, B, and line AC there? And then now they give us an angle at the circumference. And then remember, this angle here is twice the angle at the circumference. So the center will always be 2 times the angle at the circumference. Be careful now. This simply means your center must always be bigger than what? The circumference. If it happens that you calculate and find the angle at the center is bigger than the angle at the circumference is bigger than the center, you must know that now you are going wrong. Center must always be bigger than circumference. Okay, let's look at the other way of tracking the center and the circumference. Now, what is happening here is like I have dragged this point here and then continue dragging it up to somewhere here. Okay, then you'll see this line as if it has overlapped on top of that one. That is the second diagram that we are having there. Okay, and then now the AB line have overlapped over the OB line there. Hence, we are seeing only one line, which is line AOB there. But it doesn't change the issue that we are having what? Center angle, which is twice angle at the circumference. And then grade 12, you must look at the capping of angle. They are capping in the same direction. If it is capping up, they will both go up, okay? And then now that is the center and the circumference angle. I am continuing now dragging that point A. Remember, we put it there and then we drag it to somewhere here. And then if I am dragging that point to there, I end up with the AB line. Remember the line that has overlapped to that one? I have just moved the line to that point. Therefore, it shows a diagram in this format. We are using still the initial diagram that we were having on the first diagram. So we still have our center angle here, and then the circumference angle, which is angle A there. Center, twice, circumference. Okay, lastly, our diagram, okay, it's like I am still dragging that point A here, and then continuing dragging that down up to the A is now there. And then it creates this last diagram that we have there. And then now look at this, our center angle will now be that one, goes with the circumference, that one. So the misconception, grade 12, is that learners are taking this angle here, thinking that that will be the center. Let's call it O2. They will take O2 as if it's the center angle for A. That is not true. In order to be the center angle, they must cap in the same direction. Look at that, capping is facing downward. The same applies with the center, which is twice, it will face downward. So that is how you track or identify your center angles. Grade 12. Angle center, twice angle circumference. Check for those 4 diagrams on your rider. Okay, and then now the vertex of the circumference angle must touch the circumference, vertex must touch the circumference, and then the center must be at the center now. All right, and then the misconception about this last one here is that some learners, they think that ABOC is a cyclic quad. Grade 12, in order to be cyclic quad, all 4 vertex, all corners of your quadrilateral must touch the circumference. But in this case, you can see that it's only A, B, and C that are touching the circumference. Therefore, there's no way that this diagram can be a cyclic quadrilateral. That is a misconception, all right? And then there is another misconception with this one, whereby learners, they think these are angles on the same segment. They only check, okay, there's that bow tie diagram, therefore I am seeing a same segment. They cannot be same segment. Remember, for same segment, all the corners of that segment must touch the circumference. All 4 angles must touch the circumference. Look at this now. We have 1, 2, 3. Can you see that O is not touching the circumference? Therefore, this is not the same segment. To be same segment, all the vertex must touch. 4 of them. All right. The circumference. I hope this is clear now. And then the last center theorem, we are classifying 3 now. Line from center to the chord. The second one, angle center circumference. The third one will be angle in the semicircle. Semicircle means what? Means half. Why is it semicircle? Because it is subtended by the diameter. It is held by a diameter line. Remember, I've indicated initially when we were naming the lines that a diameter cuts a circle into 2 equal halves. Therefore, this theorem is using that application now. We have a diameter line given to us as diameter AC there. As you can see, we have that line there, that is line AC. And then the line, this line must touch the circumference because it's the diameter at 2 points. So you track the lines that are moving from those circumference points, okay? And then this is the first line to the circumference, and then another line C, B to the circumference angle. And then the emitted B there, therefore that will be your 90 degrees angle. So this is the angle subtended by a diameter. It will always be 90 degrees or angle on semicircle. Right, now we move to class number 2. In a second class, it's where we are checking the chord, angle subtended by same chord, angle subtended by equal chords, and then angle on the same segment and so forth, okay? And then now the correct way of writing this reason grade 12 abbreviated is angles in a same segment. And then now let's look at this. Remember we said this is a chord initially, and then that is an arc, and then this is the segment. So now we talk of angles that are subtended by the same segment. We are having segment BC here, okay? And then from here now we move from the point of contact to the circumference then, and then try to track which angles are equal. So you can see that angle E, it is subtended by that same segment. Can you see that, great terms? And then moving to angle D from the same segment again, we have angle D there. So those are the lines that are leading you to that angle D. So those particular angles will be now equal. As you can see, they have indicated XX there to show that these two angles are equal. The same applies. We can have the same segment here. If you have a chord there, you can have a segment ED there. Okay, that segment can also hold equal angles. Which are those angles? That is the angle EBD and angle ECD there. They are also from the same segment, same chord, same arc. Therefore, but our reason we write it in angles in the same segment. All right, great Charles. And then now another converse for that one is that equal chords subtend equal angles. It's like now I am dismantling those two triangles there. I am shifting maybe one triangle to the side and another one, separating them like that. Since now they come from the same chord, look at this now. We are having chord CD there, and then this chord FG, and then it is given that they are equal then. Okay, if that is the case, they must both be a chord grade 12, equal chords, equal angle. If I'm having chord CD here, and this chord CD is subtending angle E on the circumference, they must touch the circumference then. And I'm having another chord, and they say this chord is called FG, and there's an indication that these two chords are equal. Therefore, it also subtends equal angle on the circumference. This simply means now a chord FG, since it is equal to chord CD, therefore angle H will be equal to angle E. Why? Because equal chords subtend equal angles. Okay, so you can also write equal chords, equal angles. It is also acceptable. And then it is very important that our reasoning is according to the acceptable geometry reasons. If you don't have that copy, please ask your educator. It is from our examination guideline. So it must be extracted there. All learners must have a copy of that. Your reasons in geometry, it must be in terms of that particular acceptable geometry reasons. Now we are moving to class number 3, grade 12. And then in class 3, we are talking the cyclic quadrilateral theorems. How many do we have there? We have 2 theorems. And then the first theorem says that opposite angles of a cyclic quad are equal. Not equal, they are supplementary. Sorry for that. Opposite angles of a cyclic quad, they are supplementary. What do we mean by supplementary? We mean they add up to 180 degrees. Which angles are opposite now? Look at this now. This is a cyclic quad. How do we know? How do you test? It must be a 4-sided figure inside the circle. That is why we say it's a cyclic quadrilateral. It's a quadrilateral inside the circle. And then, but what is special about this one? All the vertex must touch the circumference. All the corners, 1, 2, 3, 4, they must all touch the circumference. If you have a quadrilateral inside the circle, 4 corners touching the circumference, therefore that is a cyclic quad. You can now apply the theorem opposite angles of a cyclic quad are supplementary. Which angles are opposite now? We have angle G, which is opposite angle E there. So if we add these two, they must give us 180. Or you can take the angle H plus angle F. They must also give you 180. That is the application of that particular theorem. And then moving to the next theorem on a cyclic quadrilateral. How do you know it's cyclic? It must be a 4-sided figure inside the circle, and then it must have 4 vertex touching the circumference. Therefore, this is a cyclic quadrilateral. And then what does this theorem state? It says exterior angle of a cyclic quad is equal to the interior opposite angle. And then how do you track this exterior angle, grade 12? That angle must be on the extension of one side. As we can see that we have this exterior angle here that is indicated with an X maroon there. And then now look at this angle. It is on the extension of one of the side of the cyclic quad. The line JM is now extended to N. So it is creating that exterior angle, which is NML. And then now this is equal to the interior opposite. How do you check the interior? You come in here, you pass that one, and then that will be your interior opposite angle. You can even go the right hand side. Starting from there, you come in, you pass this one, and then that will be your interior opposite angle. Therefore, these two angles will be exactly equal now. The difference with this one, they are equal. Hence, with the opposite, the sum of the two is 180, grade 12. Do not confuse the two, all right? They must be exactly equal. We can even track another one. Let's say we take KJ and then we extend that sign. That means this will be the exterior angle now of that cyclic quad. Remember, we want to track in the interior opposite, come in, pass. That means that will be the interior opposite L there. Okay, I hope it is clear to you. And then let's look at the last class of our circle theorems. And then we have class number 4, which is the tangent theorem. How many tangents do we have? We have 3 theorems. The first theorem is tan perpendicular to radius. That means it is relating to the tangent and the radius. What is our radius now? Our radius is OF line, and then the tangent is the GFH line. So if this theorem states that an angle between a tangent and the radius is equal to 90 degrees, as you can see the curve there. As long as we have a tangent and the radius, the tangent is perpendicular to radius at the point of contact there. Therefore, it is 90 degrees angle. OFG is 90 and OFH, it will also be a 90 degrees. So the second theorem on the tangent theorems is tan from the same point are equal. So you have a point outside the circle there, and then those tangents are drawn from that point. As you can see that you have tangent GHI there, and another tangent from GEF there. So now this tangent, the point of contact is that H, and the point of contact is F there. So this tangent will be equal from F to G. From point of contact, grade 12, be careful, and then from H to G there. They are equal, as you can see that there's an indication that they are equal. Okay. And then from only the point of contact. Some examiners, they can also bring in this theorem of tan chord by drawing a tangent there. Then you must know that it is perpendicular from the previous one. Draw another tangent there. And then this will also be perpendicular. Radius, sorry. Drawing radii from that point to the tangent, then it forms a 90 degrees. It forms a tan perpendicular to radius, right? And then now, remember a radius, they are equal throughout the circle because it's a line from the center to the circumference. And then if you look at this, now we have formed a kite there. So there will be an application of the properties of a kite. So grade 12, ensure that you understand the properties of your quadrilaterals because they can be tested in relation to your circle geometry. All right. And then the last theorem, we have the tan chord theorem. With the tan chord theorem, we have a tangent FEG there. That is our tangent line. And then now we want to track out the tan chord angle. We move from the tangent to the chord, and then now we found chord CE. And then from chord CE, we track the angle that is subtended, held by line CE. So this is taking us to angle D there. Can you see that, grade 12? Therefore, that will be an angle that is equal to the angle FEC. Okay, the same way we can go from this side here, from the tangent to the chord, that is creating angle GED. And then now to track an angle, we are going to see it on that particular chord here, because it's from the tangent to the chord. So as we continue, we found that chord ED, and then now we track an angle from there that we can see that this line is subtending angle C. Therefore, C will be the angle that is equal to angle GED. So basically, grade 12, we are having 4 classes of the center theorems, and then you must be able to identify them on your diagram. And then let's look at the application now. All right, the first example, remember our hints said read the statement, ensure that all the given information is on the diagram, indicate equal angles, highlight everything, okay? Now, let's start. In the diagram, O is the center. Yes, we have O there as the center. And then LOM is the diameter. The minute they talk diameter, you must think of what? A 90 degrees angle. Therefore, there must be a theorem that angle in semicircle. That is the first theorem identified by that statement, diameter. Okay, and then they say ON, line ON, bisect chord LP. As you can see that there's an indication of bisection there. The minute you see a line from center bisecting the chord, that means it's your theorem line drawn from center to the midpoint of the chord. This is now creating what? A 90 degrees here, grade 12. Can you see that? You have another 90 degrees. Diameter LM has created a 90 degrees on P because it is subtending angle P. I am reading the statement, putting the information on the diagram. That means now I'm having the second theorem here, which is line from center bisecting the chord. Okay, and then now T and S are points on the circle on the other side of LM with respect to P. There is nothing coming out of that one. And then we have the chord PM, chord MS, chord MT, chord ST are drawn, and MTS is equal to 31 degrees. Angle MTS 31. There we are, grade 12, we have our angle there being at 31 degrees. Then I've gone through everything, statement, and indicated some information as I am reading my statement into the diagram. Then I go back to the diagram and analyze. Do I have some hidden information somewhere on the diagram, grade 12? Look at this. I have not yet checked which angles I must calculate. I am analyzing the statement together with the diagram before answering any questions. All right. And then now when I look at this diagram, I see that PM is given as being MN equal to MS. But this information is not on my statement. That is why it is very important that you also analyze your diagram. And then now this is bringing to our attention that theorem which says what? Equal chords, because we have a chord PM that is equal to chord MS. So grade 12, what is it giving us now? It is giving us that angle L is equal to angle T, because equal chords. So this will also be 31 degrees. Okay, everything analyzed, we are done now. Can we start answering the questions? Yes, we have all what we need. As you are answering grade 12, please ensure that you also bring in angles on the straight line, exterior angle of a triangle, sum of angles of a triangle. Those early grade 10 application of geometry, they are also applicable on this particular grade 12 geometry. Right. And then now I'm looking at this diagram, trying to find out, did I miss any theorem now? Right. Remember, we have the third one, which is what? Equal chords, equal angles. Right. So I'm having a center. Now I'm starting testing all my theorems. I have center. Okay, center. Okay, the first theorem of angle, of center angles, it says the line drawn from the center to the chord. Okay, do I have that theorem? Yes, I've already indicated that is line from center bisecting. I'm testing my theorems now. Second theorem on center theorems. It says angle at the center is twice angle circumference. Is that applicable here? Yes, I'm having a center angle here, which is this one. Okay, do I have any angle at the circumference in relation to that one? You check those diagrams. Remember, we have 4. Yes, we do have. Look at that one. It is giving us the circumference angle. That means also angle at the center, twice angle at the circumference is also applicable for this particular rider. The last center theorem is the angle in the semicircle, okay, or angle subtended by diameter. Is that applicable? Yes, because we have a diameter line there passing through the center. Therefore, it is subtending that P angle. Therefore, P is 90 degrees because of angle on semicircle. We have already indicated that, grade 12. Then we are done with the center. We are testing now the second class. Second class is talking to the segment and chord. And so equal chords, equal angles, and then angles on the same segment. Same segment must form a bow tie, but all the vertex must touch the circumference. Do we have that bow tie touching the circumference? No, it is only the center and circumference one. And then now, do we have equal chords? Yes, we do have. We have already indicated that theorem. Equal chords, equal angles. Okay, can you see how easy can you analyze that? And then now we look at the last class. The third class, grade 12, the third class is talking to the cyclic quadrilateral four-sided figure inside your circle, all vertex touching the circumference. Do we have such diagram? No, we don't have a four-sided figure that touches the circumference. So we are not going to even look into the cyclic quad application because we don't have a cyclic quad. Lastly, we talk tangent. Do we have a tangent line there? A line touching circle at one point outside? No, we don't have. So that means from cyclic quad up to tangent, we are not applying those theorems. On this rider, we will only look at the center theorems, and then equal cos theorem. That is the applications. Now, grade 12, that we have all the information that we need relevant to the diagram. It is only then that we can start solving. This will avoid us from giving too much information which is irrelevant to the diagram. Okay, let's calculate. We said we start from the known to unknown. And then what is the known angle here? We are having angle T given as being 31 there. And then now, where can this lead us to? It can lead us to angle L because we are having equal cos there. Okay, let's start answering the question, grade 12. So we are saying angle L will be equal to angle T. They are both equal to 31 degrees. The reason being equal cos, equal angles. Equal angles. Okay, and then now after calculating, you put in the answer on the diagram as I've already done that there. And then secondly, let's check now grade 12. Where can this lead us again? Remember, we have that 90 there. You must talk to that 90. Where does it come from? Okay, as you can see from the diameter. Oh, we can also say secondly, angle P is equal to 90 degrees. What is making that equal to 90? Because it's an angle in semicircle or angle in half circle. Okay, or angle subtended by diameter then. Okay, indicated that 90. Remember, we have indicated another 90 then. And then we can also talk to that because our questions are open. We are calculating all possible angles, grade 12s. Okay, and then now we can, so, okay, number 3 say angle N1 will be equal to angle N2. They are both equal to 90 degrees. What is making them to be 90 is because of the line drawn from center. Line from center to the midpoint of a chord. Okay, that is the theorem that is creating that 90 degrees. Doing very well, grade 12. Let's check other angles that we can calculate now. Okay, let's look into the triangle PML. Remember I said you can also apply sum of angles of the triangle. In triangle PMN, we have this angle here. We can call it M1, M2, M3 there. I'm talking to angle M1. We can find the sum of angles of those triangles. Therefore, we can conclude out of that triangle that angle M1 is equal to 180. Where does 180 come from? Sum of angles of a triangle. So we subtract other angles, minus 90 from P, and then minus 31 degrees from N. And then if we subtract these two, now we end up with 59 degrees. And then now where does 180 come from? Our reason will be sum of angles of a triangle or the interior angles of a triangle. Now after calculating, put the value into the diagram. This is 59 degrees, grade 12. Okay, let's continue now. All right, we have not applied the center and the circumference, okay? We can now calculate, let's call this O1, O2, and then maybe that one O3 and O4, that's it. Now we want to calculate O3. And then to find the value of O3, look at O3, that is the center angle for T. All right, then we are going to say angle at the center, which one is center, is O3. Angle at the center is twice angle at the circumference, which is T. Our reason angle center is twice angle circumference. And then now, how much is T? That will be 2 into 31 degrees, which is giving us how much? The 62 degrees. After calculating this, we put the value into the diagram. 62 degrees, grade 12. Can you see how easy can we do that? Okay, now let's look at the diagram again. Which angles can we also calculate? In triangle OMS, in triangle OMS. We are talking to this triangle here. All right. We have the center angle 62 there, but we have the lines. Line OM is equal to OS. This line here is equal to this one. And then why are they equal? OM is equal to OS. Why? Because they are radii. Line from center to the circumference, from center to circumference, they are equal. Radius is equal throughout your circle, okay? And then if this is the case now, we can now conclude that angle M2 plus M3 is equal to angle, let's say this is S1, S2, it will be equal to angle S2. And then what it is making those two to be equal is because they are angles opposite equal sides. That is the correct reasoning, grade 12. We don't want to see base angles of a triangle. We don't want to see reasoning isosceles triangle. The correct reason is angles opposite equal side. If we have talked to angles on your left, your reasoning will start with angles. Therefore, it's angles opposite equal sides. Now, how are we going to find the values for this? Remember, the sum of that triangle is 180 degrees. And then we are going to subtract the 62. So the remaining value there will be divided by 2 to be shared amongst those two. And then this is giving us how much? 180 minus 62. It will be 118. And then we divide that by 2 for each angle. Therefore, we will end up with 59. This comes from sum of angles of a triangle. Therefore, this will also be 59 degrees. And this is also 59 degrees, grade 12. Basically, we have calculated the values of that particular triangle. And then in this case, remember this N1 is also 90 degrees. You can also calculate angle O1 in that particular diagram because we have 90, we have 31 in triangle LNO. LNO. Okay, and then now, grade 12, we can also find angle O1. We'll say 180 minus 90 minus 31. Okay? And then this will also give us a 59 degrees. All right. What does it mean to you now? What can you tell me about line PM and line NO? Look at this now. We are having P there is 90, and then we have N1 being 90 there. We have angle M1 being 59, and angle O1 being 59 degrees. So, grade 12, if you look at this, we have the corresponding angles between the F shape there. This angle, remember, will be equal to that one. If the angles that are corresponding are equal, therefore the lines are parallel. So that we can also be asked to prove that line PM is parallel to line ON. I think we have exhausted the question, grade 12 now. Let's move on to the next one. Okay. The same hints, same tips. You look into that given statement, read it twice in the diagram, a circle with center O, yes, we have O there, through PQ, PQRS, yes, and then PR is a diameter, happy. The minute we see diameter, we know that there is a 90 degrees somewhere. Let's look which line is diameter, line PR. Which angle is it subtending? It is subtending Q. Okay, that means this whole Q angle here will be 90 degrees. So that is the first theorem, grade 12, that we have identified, that we have angle subtended by a diameter there. And then we are given POQ is 114. POQ, yes, it is indicated, is that angle there. And then SPR. SPR is 32, yes, it is indicated on the diagram. And then calculate all possible angles. You know the tip, grade 12. Look into the diagram, check, do you have center? Yes, check the center theorems. Do we have a line from center to the midpoint or perpendicular to the chord? No. Do we have angle center twice angle circumference? Yes, because there is that diagram there. Okay, look at this. You have the diagram there to the circumference, or you can even take it this way. All right, to R. That is another center diagram. So we have two angle at the center, twice angle circumference. Two angle center, two angles that apply center, twice angle circumference. Okay, that is the first one, correct? And then now let's check another one. We are still on center. Do we have the angle subtended by diameter? Yes, because there's a diameter line PR. It is subtending Q. We have already indicated that. So we have angle on semicircle. All right, done center angles. Then we go to chord, segment, and so on. Segment, same segment. We check for the bow tie. And then are all the vertices touching the circumference? Yes, we have a bow tie shape. Check the vertex as touching. Therefore, we can apply angle on same segment. Do we have equal chords? No, we don't have. Class number 2, we pass. We go class 3, cyclic quad. Cyclic quad is four-sided figure inside the circle. All the vertex touching. We do not have a four-sided figure inside the circle. So we pass that one. We go tangent. Do we have tangent? We don't have a tangent line. We exclude. So cyclic quad and tangent we are not using. So we will rely only on center and the segment theorems. All right. Do not forget exterior angles, sum of angles of a triangle, angles on a straight line, and so forth. Let's start now from known to unknown. Okay, let's look at this 114. Where is it taking us? It's a center angle. Therefore, it goes with that circumference angle. All right. Angle at the center. We start as it is stated on the theorem. Angle at the center. Which angle is center? O2 is twice angle at the circumference, which is S. Reason angle center is twice angle circumference. All right. And then which one is given? O2, S114 is twice S. Divide by 2 both sides, therefore we end up with angle S being how much? 57. Okay. Correct, great terms. We have our center angle then. Okay, now look at, we want to apply this angle on same segment now. Look at S and R. They are both on the same segment SQ there. Okay, so now we can say angle S is equal to angle R, which is equal to 57 degrees. What is making them to be equal? Angle on same segment. All right. And then now let's continue grade 12. After calculating, do not forget to put the values on the diagram. They might help you to find other angles. Remember, we are answering open questions. Why are we doing them open? Because you don't know, examiner will choose which one. Even if when you are revising your writer's grade 12, do not look at the questions. Check all possible angles that you can calculate on your own without referring to the question asked from you. All right, let's continue now. Now in triangle PRQ, we have two angles now. We have Q there, which is 90. We have R, which is 57. Have we talked to 90 somewhere here? No. Therefore, we must tell why is Q 90 degrees. Angle Q1 plus Q2 plus Q3 is equals to 90 degrees. What is making these three angles to be 90 is because they are angle in semicircle or angle in half circle. They are subtended by diameter. Okay, hence we have that 90 kept there, grade 12 is because of the diameter. So in that triangle, we now have two angles. We can calculate angle P2. So therefore, angle P2 will be equal to 180 minus the 90 degrees of Q minus the 57 of angle PRQ. Okay? Then this will give us how much? 180 minus 90 is 90. And then 90 minus 57, I think that is 33. Okay, therefore this will give us a 33 degrees there. That is angle P2 will be 33 degrees. I hope we are still together, great terms. And then now let's continue. From there, where does this P2 lead us to? Look at this P2 is in triangle OPQ now. Triangle OPQ now. In triangle OPQ, we have P2, 33, we have O2, 114. We can calculate Q1. Same method, sum of angles of a triangle, all right? We are now in triangle OPQ. So we state that angle Q1 will be equal to 180. We subtract what? 33 for P2. We subtract 114 degrees from the center angle. And then this Q1 will give us how much? The Q1 is 180 minus 33 minus 114. This is giving us a 33 degrees. Look at this, grade 12. Why is this angle Q1 equal to the angle P2 there? It's because OP is equal to OQ, which is a radii, correct? And then therefore, remember radii are equal throughout your circle. We can even use those radii to calculate this angle by saying angles opposite equal sides. Okay, we can even find the value of O1, grade 12. O1 plus O2 is equal to 180 degrees, reasons angles on a straight line. Therefore, this will give us how much is O2, substitute 114, 180. Therefore, angle O1 will be equal to 180 minus 114, which is giving us a 66 degrees. So this will be 66 degrees there. Okay, you can continue, grade 12s, looking for other angles continuously so until you have exhausted the diagram. I think we have now exhausted this one. Okay, and then if you look at this again, grade 12, it has a relationship with that 33. This is the center angle of that one. As you can see, that is double that particular angle. Let's continue. Okay, let's take another example again. In the diagram, ABCD is a cyclic quad. It is given to us, it's a cyclic quad. The minute they say cyclic quad, we bring in theorems of cyclic quad. So we will look at the opposite angles of a cyclic quad. We'll look at the exterior angle of a cyclic quad. Okay, because we can see that there is an extension of sides there. All right. And then now AD and BC produce to meet at E. And then CA bisect. To bisect is to cut into equal parts. Okay. CA, the line CA is bisecting angle BAD. That means this simply means now this angle here will be equal to that one in value. Okay. And then now CD is perpendicular to AE. CD perpendicular to AD. There's a cap there that is indicating that 90 degrees. And then now we are given that BAD the one that they indicated is bisected there, is equal to 76. So if you are bisecting 76, cutting 76 into 2 equal halves, that means each angle there will take how much? The 38 degrees. Therefore, each of this will be 38 degrees because it is bisected. Okay. And then now, grade 12, we have taken all the given information into the diagram and then highlighted where there's a need of equal angles and so forth. And then now we look into the diagram and check, is there any theorem that is missing from our classes of theorems? Number one, we have center theorems. Do we have a center? No. So we don't even look at the center theorems because this diagram is not having a center. Do not assume that F is a center unless it is stated as being a center or there's a dot that is indicating the center. If there is none of the two, do not assume that F is a center. That is a misconception. Okay, and then now we are not going to look at the center theorems. We look at the second class. Do we have the segment, that bow tie shape with the vertex touching the circumference? Yes, we do have that crossing with the vertex touching the circumference. That means we can also apply what? Angle in same segment. Okay, do we have equal chords? No, we do not have. There's no indication of equal chords, no application of equal. We pass that class, we go to cyclic quad. Yes, it is there because it is even given in our statement that there is a cyclic quad. Therefore, definitely, we will apply the cyclic quadrilateral theorems. Okay, great terms. And then now we look at the last class. The last class is the tangent class. And then with the tangent, there must be a tangent line. And then some learners, they will assume that DE is the tangent and CE, and they will end up saying those two are equal. That is a misconception. To be a tangent, it must touch the circle outside. One point of contact, not going inside the circle, grade 12. They mean that the line goes into the circle, it is not a tangent. To be a tangent, it must touch a circle at one point, at the point of contact, and it must be outside the circle, not inside. And then now 1.1. Calculate with reasons the sizes of the following angles. We are expected to calculate angle A1. We have already done so, grade 12. Can you see the smart way of analyzing your diagrams and everything? You already have the answer for A1. What is A1? A1 is equal to 38 degrees. Where does it come from? From the CA bisect BAD. That is our reason. From the given information that the CA line bisect the angle BAD. Okay, we have a 38 degrees indicated on the diagram, yes. And then now 1.2, calculate B1. Look at B1 there. Okay, that means they are inside the bow tie there. Can you see the bow tie diagram? So they both come from the line DE there, or segment DC, segment DC, and then it is holding angle A1 and angle B1 there. Therefore, B1 is equal to 38 degrees from A1, angle A1, which is equal to the 38 degrees. What is the reason for that? Angle in same segment. Okay, then after calculating the value of an angle, we add it on the diagram. Then B1 will be 38 degrees. Continue, grade 12. 1.3, we are now looking at B2. Look at B2, grade 12. Can we relate B2 to any angle? If you look at B2 now, it is having a relationship with that exterior. We have cyclic quad A, B, C, D. Can you see that? And then we have an angle that is exterior. One side AD is extended to E there. And then it is creating this 90 degrees angle D3 there. And then remember we said we will come in, pass angle A and go to B. That means the angle B, both 1 and 2, when you add them, they will give you a 90 degrees from D. Okay, grade 12. After that analysis, okay, we are now concluding B1 plus B2 is equal to angle D3. Why is it equalizing them? Is because of the exterior angle of a cyclic quad. And then let's substitute. We know the value of B1 is 38 degrees plus B2 equal to D3. Therefore, B2 will be how much? The D3, we can even put the D3 value there, which is 90 degrees, grade 12. Therefore, B2 will be 90 minus 38, which is how much? 52 degrees. So happy now, the B2 is 52 degrees. We are done with that answer there. And then 1.4, we are calculating angle BCD. And then we are looking for BCD there. This angle here, that means we are basically looking for C1 plus C2. That is our BCD angle. And then if you look at BCD, this angle here, it is opposite angle A inside a cyclic quad ABCD. Therefore, we can apply the cyclic quad to solve that one. We are saying angle C1 plus C2 is equal to 180 opposite angles of a cyclic quad minus, we are subtracting the opposite ones, which is 38 minus 38 degrees. Why grade 12? Because opposite angles of a cyclic quad are supplementary. So this angle here plus that one is equal to 180. So if I want this one, I will say 180 minus those two there. Then the C1 plus C2, remember, is representing BCD. I have indicated there. And then this will be 180 minus the 38. Therefore, this is giving me 104 degrees. Therefore, this value of this angle will be 104 degrees. Okay, 1.4 answered. And then now look at 1.5. We are looking at angle E. E is that angle there, out of the circle there, okay? But this angle lies in triangle AEB, correct? And then let's check in that particular triangle AEB. Okay, we have the value of A, that is 38 plus 38. We have the value of B, that is 52 and 38. Can you see, grade 12, the importance of writing the information into the diagram as you are calculating? It will assist you to find other angles. And then now we can now calculate E using that triangle AEB. Okay, angle E will now be equal to 180 degrees. Then we subtract the first angle there, that is angle A1 and A2, which is 38 minus 38 again. We go B angles, we have minus 52, and then we minus the 38. And therefore, what is remaining there will be the value for that particular E angle. Let's do so, grade 12. It's 180 minus 38 minus 38 minus 52 minus 38. Therefore, we are left with how much? The 14 degrees. Therefore, that is the value of angle E there. And then one other angle may start by calculating C3 there and decided to use triangle DCE. If you decide to use DCE, you must start by calculating C3. And then C3 is forming straight line with C1 and C2. So you'll take 180 of a straight line and subtract 104, grade 12, and then this will give you a 76 there. That is another way of finding this. And then from 180 of the triangle DCE now, DCE we have 180 for sum of angles of a triangle. Then you subtract 76, you subtract the 19. It will still give you what? The 14 degrees there. Okay, remember, this is because of sum of angles of a triangle. I think you have exhausted everything, grade 12. And then one other thing now, one question that may rise here is that prove that is our number 2, that AC is the diameter. Or you can even calculate, before we go there, the D1 plus DC is a straight and forward. You can find that is 90 degrees. And then you can calculate D2 grade 12 if you want. In triangle BDC, it is possible to calculate sum of angles of a triangle. You can find that value there. You can find D1, sum of angles of a triangle in triangle ABD. So I am just bringing this to your attention because the examiner can choose any angles to be calculated. That is why I'm saying always ignore what is asked from you and try to find everything, even beyond the questions that were asked from you, so that you can be safe with any question on that particular diagram. All right. And then now let's look at number 2. Prove that AC is the diameter. AC, we are looking at this line here. Line AC is that line. Okay, great, Charles. We have already done that. Can you see that? In order for that line to be a diameter, it must subtend, hold an angle of 90 degrees. We have just proven that this angle D1 plus D2 is equal to 90. And then look at B again. You can even use the B there. You say B1, let's check. B1 plus B2, it will be equal to 52 plus 38. And then if you add the two angles, they give you a 90 degrees. Therefore, line AC is a diameter. Okay. Why are you saying it's a diameter? Is because we have used the converse. We are not using angle in the semicircle, but we are using the converse of that theorem, okay? Converse angle in semicircle. Converse, because we are conversing. Remember, we did not start from diameter to the angle. We are now starting from an angle to a diameter. That is why we are adding a converse, because we are using the converse of that particular theorem. Okay, grade 12, I hope we are still together. Let's continue. All right. Another example, or it's the same one as the previous one. We are done with that one. And then let's look at this one now. In the diagram, circle C, D, E, F. We have our circle C, D, F, E there, okay, is given with a straight line C, D, and E, F meeting at H. There we have those lines, yes, in our diagram, yes. And then FC, bisect, there comes again the bisect. Bisect, cut into two equal. Bi means two, so if you are bisecting, you are cutting into two equal parts, okay? So the FC line, this line here, FC, is cutting angle ECH. That means this 72, remember, it belongs to the whole angle, as indicated that. So if we are bisecting that angle, that means each part here will take half of 72, right? So bisected 72, therefore each will take what? A 36. So this piece here will be 36 degrees, and also that one is taking a 36 because the angle is bisected. And then now, angle CDF is 100, as you can see that. CDF, we mean the whole D, we can say D2 and D3 there. So the whole of D2 and D3 is equal to 100 degrees. Remember, you always start from known to unknown. Let's look at the first. Before we go to the first question, we analyze the diagram. Remember, we start with the statement and show everything is into the diagram. We now analyze the diagram and check which theorems can we use in this particular diagram. Do we have center? No, no center given to us, for we are not going to use the center theorems. Do we have the segment or chord theorems? Same segment. We look for the bow tie touching the circumference. Yes, all the vertex of this bow tie shape inside here, it is touching the circumference. Therefore, we can use angle in same segment as one of our application. Number 2, do we have equal chords? No, we are not going to use equal chords. We move to the next class. Next is saying cyclic quadrilateral. Do we have a four-sided figure in the circle? Yes, we do have. CDEF is a four-sided figure. Do we have all the vertex touching the circumference? Yes, therefore we can use what? Opposite angles of a cyclic quad. Okay, that is how you analyze. Do we have an extension of one side of that cyclic quad going out? Yes, we do have CDH extended. We have EFH extended. Therefore, we can use the exterior angle of a cyclic quad. It's also applicable then. Okay, we are done with cyclic quad theorems. We now check, do we have tangent? We do not have a tangent line. The minute there is no tangent, there is no way we look into those theorems greater. That means tangent is not working for us, center is not working. We are relying on segment and cyclic quad to solve our problems with straight lines, sum of angles of a triangle, and so forth. Now we can now start answering the questions because we know where we are going. Okay, 2.1, calculate FCD. FCD. Grade 12, you can name your angles. Remember, you will be having a diagram sheet. You can name your angles using numbers. You are more than welcome. That means it's E1, E2. Then you can say C1, C2. And then we have F1, F2. We can have F3 there. And then with D, we have D1, D2. It's up to you, okay? But you must indicate on the diagram sheet which angle are you talking to. And then now here we are looking at FCD. FCD. That means in our new numbering, we are talking to C2 now. Okay? And then now let's continue now. We want to find C2. We have already done that, grade 12. Remember, this angle is bisected. Therefore, the 72 is shared equally amongst those two angles. Therefore, we can conclude, okay, therefore, angle FCD will be equal to 72 divided by 2, which is giving us a 36. Where does it come from? Is because they've indicated that FC bisect angle ECH. Done. Okay? And then now 2.2, DEF. Let's check what is DEF. DEF. Can you see we are talking to E2? We have just named that angle E2. It is making our life easier now. Now look at E2 now. Okay, oh, I can see that this E2, I'm having that bow tie. Remember, you can highlight your bow tie, grade 12, so that it can clarify the angles that are equal. There we have our bow tie. Can we see the angles inside the bow tie now? This E2 is having a relationship with that 36 C2 angle. Okay, the angle E2 will be equal to angle C2, which is equal to the 36 degrees. Why are they equal? Because they are angle in same segment. Same segment. Okay, do not write bow tie, grade 12. That is not acceptable. Bow tie, we are just using them to be able to track those particular angles, but you cannot accept that as a correct reason. Reason is angle in the same segment. That's the correct reasoning. So after calculating an angle, put it on the diagram. Therefore, E2 will be 36 degrees also. We are done with that one. Remember, E2 stands for DEF. We are talking to the same angle there. Right, moving forward, 2.3, calculate CED. CED, now we are talking to this particular angle. We have named that E1. Okay, grade Charles. We want to calculate CED. All right. Look at that now. This CED, it have a relationship with that angle E is related to angle D in terms of what? Opposite angles of a cyclic quadrilateral. Okay, this simply means now we can say what? E1 plus the E2 plus angle D, that D, C, D, F, that was given to us. C, D, F, which is D2 and D3, correct, is equal to 180 degrees. Why? It's because they are opposite angles of a cyclic quad. Right. And then how much is E1? We don't know. But E2 we know is 36 degrees. Just calculated that above. And then CDF is given as 100 degrees. 180 is for the opposite angles. Therefore, E1 is equal to 180 minus 136. 180 minus 136 is giving us 44 degrees grade 12. So the value of E1 will be a 44 degrees. Okay? All right. Now, let's check now. The next question we have done with CED. CED, remember this E1 is actually our CED angle. Okay, done with that one. And then the DFE now. DFE. We are looking at F1 and F2. Ne? DFE, we are looking at F1 plus F2. So can you see that it's also opposite to C? Therefore, the DFE is also applying cyclic quad opposite. DFE will be equal to 180 degrees from the opposite of cyclic quad. Then we are subtracting the opposite angles, which is the 72 degrees. Where does it come from? Opposite angles of a cyclic quad. This angle here is opposite to that one. If I want to calculate this one here, I will say 180 minus this opposite. And then this DFE is now giving us the value of 108 degrees. All right. And then now we have 108 there, 108 degrees. Then we have calculated 2.4, 2.5, DFH now. DFH, we are looking at that F3 angle there. Okay, we are here, great chance, F3 angle. All right, then if you look at this, this is the exterior. Can you see that? You can apply exterior or you can apply angle on the straight line. It depends on you, on how to answer that one. If you are using the exterior of a cyclic quad, remember, you come in, you pass that one, that means it will be equal to angle C. Therefore, angle F3 or angle DFH, it will be equal to angle C, which is equal to 72 degrees. Why? Because it's an exterior angle of a cyclic quad. Or you can use a straight line and say DFH is equal to 180 minus 108 degrees, still giving you 72 degrees. But now in this case, we have used what? Angles on a straight line. Okay, so the value of this angle here will be 72 degrees. 72 degrees. Done with that one. And then now CHE. The CHE, look at that. CHE, we are talking to this angle here, great terms. And then now we have the bigger triangle, ECH. In triangle, ECH, do we have two angles? Yes, we have E has been 44, 36. We have C, 72. Then we can find H with the sum of angles of a triangle. Let's do so. Angle H is equal to 180 from sum of angles of a triangle. We are subtracting the first angle, 72 degrees, from C, and then we subtract the 44 from E and the 36 from E. And then the reason is sum of angles of a triangle, or the interior angles of a triangle. And then this angle CHE will now be equal to 180 minus 72 minus 44 minus 36. It is giving us a 28 degrees grade 12. I hope We are still together in that regard. We have now answered everything there. So where you have 2 marks is for the statement and reason. Where you have 1 mark, it is 1 for both, okay? 2 marks is for statement and reason. Okay. Let's look at this one with the tangent now, where we are applying tangent theorems. Okay, in the given diagram, CE is a tangent. Therefore, as you can see, it is touching the circle at 1 point and the line is outside the circle. Hence, it qualifies. We cannot say AE is a tangent grade 12 because it is going through inside the circle. Therefore, there's no way that it can be a tangent. All right. And then in the given diagram, C is a tangent. The minute we have tangent, we are going to test the tangent theorems. And then we have AC, a diameter. Look at that. Center is not indicated, but for the mere fact that they say it's a diameter, therefore AC is passing through the center. There must be a center somewhere there. Okay. And then now off circle ACG. Before we can even look at the question's grade terms, we check into the diagram which theorems are involved. Okay. Number 1, we are checking center. Do we have center? Yes, we do have. Do we have line from center to the chord? No, we don't have. Do we have angle center triscircumference diagrams? No, we don't have. Do we have angle in the semicircle? Yes, because we have diameter, therefore we have an angle in the, which angle is that one? That means G1 will be 90. So we have angle in semicircle application here. Right, we have passed the center theorems. We go to the segment theorems. Do we have the bow tie shape? No. Do we have equal chords? No. We pass, it not applicable. We go cyclic. Do we have four-sided figure? No, we don't have. We go to tangent class. Now with the tangent, yes, we do have line CE as being our tangent. Now we test the first theorem tangent. Tan perpendicular to radius. Do we have a tangent and a radius? Yes, we do. We have just identified a center there because we have a diameter. That means, what does it state? It tells us C1 plus C2 will be 90 degrees because there is a theorem tan perpendicular to radius. Okay. Next theorem for tangent, tan from the same point of contact, 2 tangents from point of contact going. Do not misconcept the line AE being a tangent. That is not a tangent. We have only 1 tangent line, which is CE. Therefore, AE is a misconception. That means the application of tan from the same point is not applicable for this one. The last one, we are checking tan chord. Tan chord will always be applicable grade 12 in most of your riders. Therefore, we are also going to look at tan chord theorem. It's a tan chord theorem, not tan chord only. It must be abbreviated tan chord theorem in full. All right. Now, this is the analysis that we end up with. Now we can start answering the questions. Number 1, we need to calculate angle ACG. ACG, that means we are referring to angle C1. That is our ACG angle. And then now look at the diagram. Can you find C1? Easy, grade 12. Can you see that if you are having G1 being 90, in triangle ACG, we already have the answer for C1. But you must start by telling us that G1 is 90 degrees. Therefore, G1 is equal to 90 degrees. Where does it come from? Angle in semicircle or in half circle. Then it creates that 90. We have already indicated that. Therefore, our angle C1 on angle ACG will be equal to 180. From sum of angles of a triangle, we subtract 90 G1, subtract 38 of A. Why? Because of sum of angles of a triangle. And then this will give us 180 minus 90 minus 38. And therefore, this is giving us a 52 degrees. Therefore, this will be 52 degrees. And then the next question then, or alternatively, grade 12, if you want to answer this question, there is another way. You can start by finding this angle C2 here. Okay? because that one is tan chord, tangent to chord. Here you stand on the chord. It is tan to chord to this one. So you can say C2 is equal to A equal to 38 degrees because of tan chord theorem. Then it will give you a 38 there. All right. And then in order to find the C1, you will say 90. Remember C1 plus C2. C1 plus C2 is equal to 90 degrees. Reason tan perpendicular to radius. So we'll end up with C1 being 90 minus the 38 of C2. Therefore, this will still give you a 52 degrees. That is another way of finding this 52. Okay. And then now we want to calculate angle E, grade 12. And then with the angle E, there is no way. You must start by calculating this 38 there for C2 here. So after finding 38 C2, we can now find E. There are two ways of finding E. The first one will be sum of angles in triangle ACE. We have angle A, we have angle C. Then we can find E by taking sum of angles of a triangle, subtract other angles. We are subtracting 90 for C, we subtract 38 for E. And then this will give us what? A 52 degrees. Okay, that is the value for angle E. Or alternatively, you can use, this one is from sum of angles of a triangle. If you don't want to use that one, you can use the exterior angle of a triangle. So we are taking in triangle CGE. Look at that, G1 is the exterior of this particular triangle. So we take G1, exterior angle of a triangle is equal to the interior opposite. So we'll say G1 is equal to the sum of the interior, which is angle C2 plus angle E. Applying exterior angle of a triangle. What is G1? 90 degrees. Remember, we are looking for E, not yet calculated that for this condition. 90 degrees, and then we have C2, we have calculated above there. C2 is 38 degrees plus angle E. So therefore our E angle will be 90 minus 38, which is equals to a 52 degrees. So grade 12, basically, we end up at the same answer, which is 52 degrees. Okay. And then now let's check. Please identify for me the three angles that are equal to 90 degrees. 2 minutes for that. Your 2 minutes starts now. Okay, great Charles. Let's see how far did you go with this one. It says in the diagram, Pn is the diameter. Okay, the minute you see the word diameter, that means you are given angle in a semicircle. So which angle is that one? That means it's Q1. Okay, so application, we have angle in semicircle. MRN is a tangent. That means the minute you are given a tangent, you will check tan perpendicular to radius. Is it applicable? Yes. Tan from the same point? No. Do not assume PM is a tangent. Ne? And then do we have tan chord? We always have a tan chord where there's a tangent. Ne? Tan chord theorem. Okay, we have addressed the tangent given to us. And then PNT and Q lie on the circle, O is the center. Everything is noted on the diagram, great Charles. Now name with reasons 3 angles each equal to 90 degrees. Can you see you have already answered all your questions, great Charles? We have a diameter that is subtending. Angle on semicircle is giving us in the first 90 degrees. Therefore, Q1 is equal to 90 degrees. That is angle in half of your circle or angle in the semicircle. And then now we have tan perpendicular is given 90 degrees. Remember, perpendicular is 90. The minute they say tan perpendicular to radius is applicable, they are telling you that this angle here is equal to 90. That is your second 90. N1 plus N2 is equals to the 90 degrees. Why? Because of tan perpendicular to radius. That is our second 90 degrees. Then we check, do we have any straight line next to the 90? Yes, we do have the Q3 plus Q2. Can you see that? This will form another 90 there because they are angles on the straight line. Therefore, Q2 plus Q3 will also give us the third angle, which is equals to 90 degrees. Where does it come from? From the angles on a straight line. Bring on those reasons, great Charles. For each statement, there must be a reason. That means to get this mark here, your statement and reason must be correct. The mark is for both statement and reason. Statement and reason in order to get that full 3 marks. Thank you very much, great Charles. This brings us to the end of today's lesson. This lesson was brought to you by Gauteng Department of Education in collaboration with Sabono Discovery Center and broadcasted by Pakama Research and Development. See you next time. Bye.